When you picture our planet, what comes to mind? You probably think of the continents, right? The land. But what if the real star of the show, the defining feature of Earth, isn't the ground beneath our feet, but the incredible, massive body of water that covers almost everything? So let's dive in and explore our ocean planet, not as just a bunch of water, but as the critical, life-giving system it truly is. I mean, just look at that number, 71%. Let that sink in for a second. That's how much of our world is covered by the ocean. It's not just a feature of our planet, it is the dominant feature. It's one single connected ocean that literally shapes everything, from our weather to our very existence. So it's pretty clear, right? If you really want to understand our world, you have to start with the ocean. So in this first part, we're going to get to know this vast system, what scientists call the hydrosphere. It's a fancy name for basically all the water on, in, and around the Earth. And the field that studies all this? That's oceanography. It's the science that peels back the mysterious surface of the water to figure out all the physical, chemical, and biological secrets of the deep. You can think of it as our toolkit for exploring this massive, watery part of our world, a frontier that, believe it or not, we're still just beginning to discover. Now, this quote just completely shatters a huge misconception. I think a lot of us picture the ocean floor as this vast, flat, sandy desert. But the reality? It's way more dramatic. It's a hidden world with a landscape that rivals, and in some cases, totally dwarfs anything we see on land. All right, so let's do it. Let's take a virtual journey down there. We're going to leave the familiar, sunny surface behind and dive deep to explore the structure and all the incredible features of this underwater world. Okay, so as you're descending, the very first thing you'd notice is the temperature change. It's not a gradual cooling. You start out in a nice, warm top layer, all heated by the sun, but then bam, you hit something called the thermocline. It's this wild zone where the temperature just suddenly plummets. And below that, you're in a massive, dark, and incredibly cold layer of water that goes all the way to the bottom. And, it's not just the temperature creating these layers. You've also got the halocline. This is a zone where the salinity, which is just the saltiness of the water, spikes up really quickly. And because saltier water is denser, it sinks, creating these distinct layers, kind of like a liquid layer cake. The main takeaway here is that the ocean isn't just a big, uniform tub of water, it's incredibly structured. So we finally reached the bottom, and there it is, that rugged landscape we were talking about. You've got the continental shelf, which is pretty shallow. You can think of it as just the continent wading out into the water. Then you hit the abyssal plains. These are the huge, super flat parts. But it's also home to the deepest places on Earth, the oceanic trenches, and, get this, the single largest mountain range on the planet, the Mid-Oceanic Ridge. It snakes around the entire globe for over 65,000 kilometers. And scattered all over this landscape, you find volcanoes, underwater mountains. The pointy ones are called seamounts, but some of them have a much cooler story. Their tops have been sheared off, flattened over millions of years by wave action when they used to be closer to the surface. We call these guyats. They're basically underwater mesas, and each one is a history lesson in geology. Okay, so we've seen the geography of the ocean floor, but the ocean is anything but still. Now we're going to look at its movement, because it's a mighty engine, constantly in motion, driven by some seriously powerful forces. This movement really comes in three main flavors. First, you have waves. Now, waves, which are mostly caused by wind, aren't actually water moving across the ocean. It's more like a ripple in a rug. It's the energy that's moving through the water. Then you have tides. That's just the whole ocean kind of breathing in and out, the slow, vertical rise and fall of sea level, all thanks to the gravity of the moon and the sun. And then you have currents, which are literally giant rivers flowing through the ocean. And you really can't overstate how important these currents are. They're like our planet's thermostat. They act as a global conveyor belt, moving enormous amounts of warm water from the equator up toward the poles, which regulates Earth's climate. Without them, the tropics would be way hotter and the poles would be freezing. Seriously, some studies suggest that a place like London would be as cold as Siberia. That constant motion doesn't just move heat around. It's a force of nature, literally. It's a sculptor, actively shaping and reshaping our world every single day, right where the land meets the sea. So think of the ocean as an artist with two main techniques. It can either take things away, which we call erosion, or it can give things back, building things up, which we call deposition. On high, rocky coasts, it loves to erode, but on low, sandy coasts, it's all about building. And the results of that erosion, well, they're pretty spectacular. That relentless pounding of waves just carves away at the land, creating these incredible steep cliffs. Waves can hollow out softer rock to form sea caves, and when a cave collapses or a piece of the cliff gets cut off, it can leave behind this lonely pillar of rock called a sea stack, just standing there against the surf. But the ocean isn't just about destruction. It's also a master builder. This is where all our favorite coastal features come from. All that sand it carries, it drops it off to create our beaches. It builds up underwater ridges called bars, and sometimes a bar will connect to the land and stretch out into the water. We call that a spect. And if a bar grows all the way across a bay, it traps the water behind it, creating a beautiful, calm lagoon. So we've seen how the ocean shapes the rocks, the land, our coastlines, but honestly, its most profound role, its most important job, is biological. The ocean is, with no exaggeration, the cradle of all life on Earth. I mean, this timeline really puts it all in perspective. Life showed up almost 4 billion years ago, and for a huge chunk of Earth's history, it was only in the oceans. And here's the mind-blowing part. The very air you're breathing right now was made in the ocean. Tiny little organisms started photosynthesizing, pumping out oxygen, and they completely terraformed our planet, making complex life on land even possible. And that's not just ancient history. That life-giving role continues every single day. The ocean is the foundation of the entire global food web, starting with plankton. It's still cranking out oxygen for us to breathe. And of course, it gives us critical resources, from the fish we eat to valuable minerals. It is the engine that keeps the whole biosphere running. So when you boil it all down, our connection to the ocean is, well, it's everything. It's our past, it's our present, and it's our future. It shaped our planet, it created the air we breathe, and it sustains us every single day. Which leaves us with one final, really vital question to think about. Knowing all of this, how are we going to choose to shape its future?